Yeah. So, okay, welcome to the tutorial. So this course is Basic Electrical Circuits. It is being offered by the instructor Dr. Ankush Sharma. He's a professor in the Department of Electrical Engineering at IIT Kanpur. I am your tutor for this course. My name is Mayank Anupam. I am also a PhD student and a PMR scholar, and I am from the Department of Electrical Engineering at IIT Kanpur. So this week, that is week 6, you learnt about Laplace transforms and its applications, right? You also learnt at the start of this week, you learnt about second order RLC circuits. Second order, which is source free, and second order RLC circuit which are forced, right? You also learnt about them. So we will quickly look at some of the problems. First at the first at the second order RLC circuits, and then at the Laplace transform applications example. Okay, so this was just a summary of the week, but whatever you have learned. By the way, pardon me for my voice today. So I am slightly sick, so my voice might be a little dizzy because I am sick today. Pardon me for that. Fine. Wait a minute. It looks like someone is trying to join. Yeah. Fine. Yeah. So this question, this example, it was solved in the lectures, right? So in the lectures, you were basically in the lecture. Sir talked about finding the current I of t, this inductor current, as a function of time after t is equal to 0, right? So in this example, I am talking about a slightly different version. I want to find out the voltage across this capacitor as a function of time. So let's see how to do that. Okay. Let me put on a different window. Yeah. So this is the question, right? Fine. Question is find what find of v of t or t greater than 0. Okay. So can you suggest, the people who are present right now, can you suggest what should I do? How should I proceed? Can you give me a pointer? Any of you? I am audible, right? I am audible to you guys. So can you please tell me what should I do? How should I proceed with this example? What should I do to find out the v of t for t greater than 0? Okay, fine. So I will solve this and you tell me whether I am doing right or not. So you can see that this is a second order circuit, right? So this here is a second order circuit. Also, you see at t at t is equal to 0, this switch is suddenly closed. Before that, the switch was not closed, and this was the case here. You see, this is 30 u of minus t. What is u of t? Unit step. U of t is like this, isn't it? This is u of t. At t is equal to 0, it suddenly rises to 1, isn't it? U of minus t should look like what? How should u of minus t look like? U of minus t should look like this, right? It should look like this. This is u of minus t. At t is equal to 0, it suddenly becomes 0. So that is what u of minus t looks like. Now you see this is before time t is equal to 0. How was the condition of the circuit? What was the condition of the circuit? So uh, this particular switch was open and this voltage was on, right? This was equal to 30 volts before t is equal to 0. So how was the condition? Let me write it here. Before t, if people want to join. Yeah, before t equal to 0, the circuit was like this, isn't it? The switch was open, right? So that part, the left part of the part which is left to the switch was not at all present before that. So I have this circuit before t is equal to 0. This resistor, this capacitor, this resistor, and there is a voltage source. And I will assume that this is the reference here. So this is 20 ohms, this is 8 millifarad, this is 20 ohms, this is 30 volts before t is equal to 0, right? Now tell me, this switch, this u of minus t, it means that this has been 1 since t is equal to minus infinity. So all the past values of t, so for all practical values, I can say that this value, this voltage source here has been equal to 30 volts for time t is equal to minus infinity till now. So I can assume that my circuit has settled till that time. This circuit, all the transients in this circuit have settled, and I will have to calculate the steady state response of the circuit, right? I'll have to see what is the voltage and at steady state in the circuit, right? So can you tell me what is the voltage at this point? This V. So this circuit here, it's in a steady state, that is assumed here, because this voltage source has been present since all the time, since all the past times. This this circuit has been in this state for a very long time now. So that is why I can say that the circuit has attained steady state, and in a steady state, you know that the current through the capacitor is equal to 0. DC current through the capacitor is equal to 0. And since we are talking about DC voltage source here, so we will talking about the DC current source, current only, right? So if the current this is equal to 0 here, so this is not this part is not this part is as good as not being present here, right? So all the current that this will be pushing will go directly through this, right? So I can say that the voltage here is equal to what? It's a simple resistor divider. So voltage V of 0 will be equal to 30 volts times 20 divided by 20 plus 20 is equal to 15 volts, isn't it? So I got the initial voltage, the voltage at time t is equal to 0 at the capacitor, isn't it? Now again, let us now try to find out. Okay, so this is the voltage at t is equal to 0. Now we know that what is the condition of the circuit which is to the left. So this is the left, this is to the left, right? This here is to the left of the switch. So this here is this also here, this here is also present in the steady state before time t is equal to 0. I can say that this condition, this circuit has been in this condition for all the past values of t. So I can say that the response of the circuit will be its steady state response, right? So I can say that the current flowing through this 20 Henry inductor is equal to 4 ampere, isn't it? Right? This current is equal to 4 ampere. So let's also write that before t equal to 0, current through the let me this. Let us see where is it. Current through the inductor is equal to how much? 4 ampere. This is because all the current that is flowing here has to flow through the inductor here, isn't it? And in steady state, the voltage across the inductor is equal to 0. Correct? The voltage here is equal to 0 in a steady state. You know that the voltage drop across an inductor is equal to 0 in a steady state. Fine. Let us also write that. Before t is equal to 0, voltage drop across the inductor is equal to 0 volts. Fine. Now let us examine the condition of the circuit after this particular thing, after t is equal to 0. Basically after that what will happen? Let me copy this so that it is visible to you now. Fine. Okay. Let's see, someone wants to enter. Yeah. So what will happen to this? What will happen to this circuit after t is equal to 0? So let us find out. Let us write here. After t is equal to 0, basically this switch will close, and this here it becomes 0, right? Because this is 30 u of minus t. Fine. So let us draw the circuit after t is equal to 0. This will look something of this kind. This is 4 ampere. This is inductor. This is okay. Someone wants to join. Yeah, this is the inductor here. Fine. And this switch is closed, so this will be like this. There is a resistor here which is equal to 20 ohms. This is 20 Henry. This is how much? This is 4 ampere. There will be a capacitor like this, which is equal to 8 millifarad, and there will be a resistor. That's all. Because this is as good as being short circuited, right? Because this is equal to u. This is 30 u of minus t. And what did I say about u of minus t? U of minus t is equal to 0 after t is equal to 0. So 30 u of minus t will be equal to 0 after t equal to 0. So basically this resistor here will be shorted to this point, and since we have assumed that this point is ground, or this point is reference here, so that is why I have written it like this. Fine. Okay. Now tell me, what do you know about the response of a second order circuit? So before that, do you identify that this is indeed a second order circuit? Can you identify this?
Yes, sir.
Right.
Combination of ILC cycle.
Correct. Right. So what is this? What can so I'll have to draw an equivalent of this, right? So let's draw an equivalent of this. This is 20 ohms in parallel, so this becomes 10 ohms, right? So this is 4 ampere. This is 20 Henry. This is 10 ohms. This is 8 millifarad. Right. Now I have to find out what? I have to find out this voltage. Sorry, this is not V0. This is just V. This is just V. I have to find out voltage across this capacitor, right? So this is V of t. I want to find it. So tell me, what is the response of a steady? What is the steady state response of a forced RLC circuit? Can anyone tell me? What is the steady state response of a forced RLC circuit? Okay, so let me give you a hint, or let me just write it here. You tell me whether you agree with this or not. So you remember that in this case, whenever you if this was not forced, right, if this current source was not present here, then what would happen the steady what would happen the response of the circuit? This would happen like this, right? V of t would happen like this. V of t is equal to a1 times e to the power minus s1t plus a2 times e to the power minus s2t, right? This would have been the condition, correct? Now s1 and s2, this, yeah, so this is assuming overdamped system. Now when you add a force, right, this is an external force, right, this current source is added externally, it will try to drive itself on top of all these things, all this in on top of this particular response, right? So you have to in that case, what is the response? That response is, since we are interested in the voltage, the steady state voltage in that case, in case of forced response, would be equal to what? I'm sorry, pardon my voice today, I'm slightly sick. Okay, so in that case, the state response is equal to what? It is equal to V steady state plus this guy, right? So can you tell me quickly what is the steady state value of this voltage, V of t? What happens after t is equal to infinite, means after a very long time, what happens to this voltage? What will be the voltage at this point? Can you tell me
40
what?
40 volts.
Why should it be 40 volts?
करेंट सोर्स और ये रजिस्टर एक में पैरेलल मैच है, तो उसको हम लोग ये वोल्टेज सोर्स में कन्वर्ट कर सकते हैं, वोल्टेज सोर्स और सीरीज में रेजिस्टेंस।
ठीक है।
तो 40 वोल्ट और 10 ओम हो जाएगा सर। उसके बाद मेरा सॉरी 0 वोल्ट होगा सर।
Right, correct, very good. So this is actually equal to 0 volt. You can directly see here, right? This is a 20 Henry inductor here. At steady state, you know that the current through the voltage across an inductor is always going to be equal to 0, right? At steady
यस
state, you know that the voltage across an inductor is always equal to 0. So you see that this voltage here, Vt, uh, sorry, this voltage here, V of t, is also it's also present across inductor, right? So this voltage VSS is going to be equal to 0. Fine. This is clear, right?
यस
Nice. Very good. So now tell me, yeah, so I know this particular guy. Now tell me what is S1 and S2. By the way, what is the metric to find out the whether a system is overdamped, underdamped, or critically damped? What do you do that? How do you do that? You find out alpha and omega naught, right? And to check whether alpha is greater than or less than or equal to omega naught, right? And what is alpha? So by the way, this is a parallel RLC network, right? So in this case, what is alpha equal to? Right?
यस
Is it 1 by RC or 1 by 2 RC?
1/RC आई थिंक।
Are you sure?
नो सर श्योर।
Yeah, so tell me.
सर यहाँ डायरेक्ट हम लोग ये लैप्लास इस डोमेन में भी सर्किट कन्वर्ट करके सॉल्व कर सकते थे ना।
कर सकते हैं, but I am trying to solve it in the way that I
टाइम डोमेन।
taught to you till now. So tell me, what is this equal to? Is this 1 by RC, 1 by 2 RC? Check it up, look it up, and tell me. Otherwise, I'll not move forward. It is discussed in this in the week, right? Tell me fast. What is it equal to?
देखता हूँ सर।
Okay, uh, it will take a long time. So it is indeed correct, right? It is 1 by RC, and omega naught is equal to 1 by root over LC. Okay, fine.
Okay.
Yeah. Now tell me, yeah. So now can you quickly calculate alpha and omega naught for these values here, for this particular circuit here? So what will be alpha in this case? So 1 by RC, right? So R is equal to 10 ohm and C is equal to 8 millifarad. So what is equal to, so in this case it is equal to 1 by 10 ohms into 8, 10 to the power minus 3. So what is this equal to? 10 to the power 2 by 8, right?
Yes.
Right. And what is omega naught? So this was equal to L was equal to 20 Henry, and this is 28 millifarad. So let's also quickly calculate that. So this is equal to inductor is equal to 20 Henry, and it is Henry, right? Yeah, and this is equal to 8 millifarad, 8 into 10 power minus 3. So what is this equal to? 1 by root over 10 to the power minus 2 into 16, right? What is this equal to? 10 by 4, correct?
So Henry na 20 micro Henry.
Micro नहीं है, it is
Oh,
Henry only, it is not micro,
yes, yes, yes,
right?
yes.
So it is equal to 10 to the power minus 2 into 16 and under root, so under root of 16 is equal to 4, under root of minus 10 to the power minus 2 is equal to 10 to the power minus 1, and minus 1 goes up, so this is 10 by 4. Fine. Now can you tell me, can you compare alpha and omega naught now? 1 minute. So yeah, now alpha is equal to 100 by 8 and omega naught is equal to 10 by 4. So clearly this guy is greater than this, right? So can you see that this guy is greater, alpha is greater than omega naught in this case?
Yes.
Yeah. So in that case, what will I have? I have an overdamped system, right? So what will be the roots for that overdamped system? What are the roots of an overdamped system? Minus alpha plus minus under root alpha square minus omega naught square, right?
Yes.
Are you convinced that yes, this is indeed the case? So what are the roots? Tell me. S1 and S2. This is equal to. I have written it equal to this. So are you convinced that this is right? Hello.
Yes.
Yeah. Fine. Okay. So no response means you are convinced. Fine. So this is minus alpha plus minus alpha square minus omega naught square. So can you tell me what is minus? What will be the values S1 and S2? This will be equal to minus 100 by 8 plus minus under root of 100 by 8 whole square minus 10 by 4 whole square. Fine. This is equal to 100 by 8 plus minus under root of, what will be this equal to? This is equal to 10 to the power 4 by 60, 64. So let me erase this. Okay. So let's put it here. 64 minus 10 to the power 2 divided by 16. Fine. So what will be the values? Can you quickly calculate this for me?
Okay, sir, calculate. 50s.
How much is this equal to?
50s. Over or 50s?
Are you sure? I don't think it is 50.
अंडर रूट एट 10 का पावर 4 बाई 64 माइनस 10 स्क्वायर बाई 16 का 50 है. यस.
50 आ गया.
यस, फिर से वो चेक कर लो. सो इस 124.
ना, कुछ गड़बड़ है. ध्यान से चेक कीजिए. So you see, this is 100 square by 8. This is 10 square by 8. This is 10 power 4 by 64. This is 10 square by 60, 16, right? You can take 10 square common from this, and 10 square when goes out of this becomes 10, right? And then after this 10 square minus 1 by this will become like this, right? After simplification. Now when you take the LCM, 64 is comes in the
यस
denominator
यस.
and the 4 comes in the
मैं थोड़ा रॉन्ग कर दिया.
this becomes 96 by 64.
12.24.
Yeah.
12.24 ओवरऑल. मतलब माइनस 100 बाई 8 प्लस माइनस 12.24.
Yeah. Okay, so what is square root of 3 by 2? So let's calculate that. I have a calculator in my mobile phone. Let us use that. Under root of 3 by 2. Under root of 1.5. 1.22. Right, 1.23. 22. This becomes equal to 100 by 8 plus minus 1.22 into 10 is equal to 12.25. Fine. If this is equal to this much, so what will be the values? Can you tell me? What will this become? Let us use calculator for this. It's 97, so
One is 0 sir, and another is minus 20.
one is what? One is 98 approximately, and one is 198. Fine. So one is minus 98 by 8, and another one is minus 198 by 8. This is approximate. These are the approximate solutions, isn't it? Okay. Now this is done. I have found out the S1 and S2 here. So these are what? S1 and S2. Now what do I need to do? I need
Sir,
to find out. Yeah, tell me.
100 by 8 is equal to 12.5.
No, no, plus minus. Here it is.
Yes, sir.
Oh, sorry. Sorry.
12.5.
Sorry. My bad. This is not minus 98. This is minus 2. Sorry. This is actually equal to minus 2 approximately. Okay. It's not equal to 0. Why did you say it equal?
नो सर, जीरो नहीं, मतलब अप्रोक्सीमेटली हम बता रहे थे, क्योंकि 100/8 तो 12.5 आएगा, और फिर 50 में से मतलब 0.25 समथिंग माइनस 0.
Yeah, so 2 by 8 is indeed almost equal to 0, right? 2 by 8 is equal to very close to 0. 2 by 8, isn't it?
Yes.
Yeah, 2 by 8 is indeed almost equal to 0. It is equal to 1 by 4, which is equal to 0.25, isn't it? Yeah, you are right. I have not calculated the decimal values. I have just put it in rational form in terms of fraction. Okay, fine. So I know that the response is equal to what? V of t is equal to VSS plus A1 times e to the power minus S1t plus S1t plus A2 times e to the power S2t. I have calculated S1 and S2. Now I have to find. I have also calculated VSS. VSS equal to 0. Now I have to find out A1 and A2, isn't it? Now I'll have to use initial conditions. I know that initially the voltage I found out, right? The initial voltage V of t is equal at t is equal to 0. You see V of 0 here I have calculated it to be equal to 15 volts, right? The voltage across the capacitor at t is equal to before t is equal to 0 is equal to 15 volts. Now we know that the voltage across a capacitor cannot change suddenly, right? So if V of t is equal to 15 volts at t is equal to 0 minus, then V of t is equal to, or should be equal to, rather should be equal to 15 volts at t is equal to 0 plus, right? Why?
Yes.
Because voltage across capacitor cannot change suddenly, right?
Yes.
Fine. Now yeah, so but I have got only one, I have to find out two values, a1 and a2, and I only have one initial condition. So from where will I get a second initial condition? Any idea?
No, sir.
Okay, so you remember that for a second order circuit we have two variables, right? And we have two things, inductor and a capacitor. Just as in an inductor, in a capacitor, you know that the voltage across it cannot change suddenly. Similarly, across an inductor, the current across it cannot change suddenly, right? So at t is equal to 0 minus, the current through the inductor was equal to 4 ampere, isn't it? So when you connect this, when it is connected in this fashion, all the current 4 ampere is going to flow like this through the capacitor, through the inductor, right?
Yes.
Fine. Yeah. So let us write that. We know that current I at sorry, what is it? 0 minus is equal to 4 ampere. So I of 0 plus is also equal to 4 ampere. Fine. Okay. Now what is the voltage? So now I need a derivative, right? I need a derivative in this case. So if all the current here, 4 ampere, is going to flow through this, basically there is no current, and okay, let's do it like this. You see this 4 ampere current is going to flow through here, right? Also you know that this voltage here and in steady state is equal to what? Is equal to 15 volts. V of 0 is equal to 15 volts. Fine. After t is equal to 0, this guy, this here is not present, so this is shorted here. So this resistor and this resistor are effectively equal in parallel, so we can replace them with an equivalent resistor equal to 10 ohms, right? So let's at t is equal to 0 plus, just after the switch is closed, what is the condition of the circuit? Let us understand that. This is a 4 ampere current source which is going to flow completely through this 20 Henry inductor. Then there is a 10 ohm resistance, right? I have written this 20 and 20 in parallel, this 20 and this 20 here. These are in parallel, so I have compressed them as to form an equivalent. And then there is a capacitor here, 8 millifarad, and voltage at that point at 0 plus is equal to what? It's equal to 15 volts, right? Fine. All this current is going to flow through this, so this part is not as good as not being present. So if there is a voltage of 15 volt across this resistor, this voltage here is equal to 15 volt between the two ends of the capacitor. Since this capacitor and this resistor are in parallel, same voltage is also present across this resistor, right? So if this voltage is present across a resistor, I know that from Ohm's law there will be a current, right? So what will be that current? This current I, let's say it is IR at 0 plus, it's equal to 15 volt upon 10 ohms, right? equal to 1.5 ampere. Is it clear?
Sir,
Yeah.
when switch is closed, the voltage across capacitor is 0 volt. Yes.
No, no. Who told that? Voltage across a capacitor cannot change suddenly. Okay, so you were not present at the start, right? So there I
Yes.
wrote,
Yes.
there I did it. You see that just after the switch is closed, no, just before the switch is closed, before the switch is closed, and this is 30 u of minus t, right? This is a this is a step, inverted step. Okay, this is an inverted step voltage. U of
स्टे
minus t
वो
looks like this.
जब t ग्रेटर देन 0 होगा तो मेरा वोल्टेज 1 वोल्ट होगा, लेकिन उससे पहले तो मेरा 0 वोल्ट ना होगा सर.
नहीं नहीं नहीं
t
नहीं,
लेस
that
देन
is u of t, that is u of t, this is u of t, but this is u of minus t here, right? U of minus t looks like this. Before t is equal to 0 it is equal to 1, and after t is equal to 0 it is equal to 0.
यस तो यस यस ओके.
Okay, is it clear
यस.
now?
यस ओके यस.
Yeah, so it is equal to indeed, so this voltage source here, this voltage source here is not present after t is equal to 0. This is just shorted here. Okay, so this resistor here and this resistor here, they are in parallel. Okay.
यस सर वोल्टेज ड्रॉप पोटेंशियल डिवाइड.
Correct,
यस
correct.
ओके
So
यस.
this is basically V of 0, the voltage across a capacitor at t is equal to 0, before t is equal to 0 was equal to 15 volts. Now that same voltage will be present across the capacitor at time t is equal to 0 plus, just after the switch is closed. You know this because the current through, sorry, because the voltage through the capacitor, voltage across the capacitor cannot change suddenly, right? So
यस.
yeah, so this is equal to 15 volt just after the switch is closed, and this will cause a current to flow through this resistor, which is equal to what? 1.5 ampere. Now this current is not going to come from this current source or this inductor, because this current is completely flowing through the inductor. Okay, just after the switch is closed. This is because the current through the inductor cannot change suddenly. Before the switch was closed, this current source was in parallel with the inductor, and all the current was flowing through this, right? The 4 ampere was completely flowing through this. So the same should happen just after the switch is closed. No current can flow through the inductor. Fine. So just after the switch is closed, my current through the inductor and this current source, they will not be contributing anything to this IR. Okay. So what will be the contributing? What will be contributing to this current? So this current will be coming from this capacitor, right? So let us see what is the current through the capacitor. It's equal to minus C
1.
dV by dt, right? It's equal to 1.5 ampere. Sorry, ampere. This is d is equal to v0 plus. Yeah. So these two, I have got initial conditions, right? I have now found out what are the initial conditions. So what is C, by the way? It's equal to 8 millifarad, right? Let us write that. Let's remove this. Let's remove this minus sign from here. To just treat it.
वाई सर माइनस साइन तो करंट तो वहां से निकल रहा है ना सर.
हाँ,
तो
right, right,
माइनस.
right. But I am trying to remove this because I do not want to create a confusion. Yeah, yeah, you are right. This current is indeed flowing out of this capacitor. So there should be minus sign, but that will be
तो
adjusted.
वाई
Hello.
तो हम लोग नेगलेक्ट क्यों कर रहे हैं? माइनस साइन भी तो मेरे लिए वो कांस्टेंट वैल्यू तो वहाँ से चेंज हो सकता है ना सर, पॉजिटिव नेगेटिव.
Ah, right, right. So yeah, that is why. So this is not required here. Okay, let's remove this. Fine. Yeah. Actually, this is required. I have removed it just for now. I will tell you how to understand how. Basically, when you put it in the equation like this right now, it becomes easier, and all the values that you will be calculating will be you will not need to do any you'll not need to use your brain after that. If you do not put a negative sign here, after calculating everything, you will have to put appropriate signs everywhere. So it is better practice to put a negative sign here. Okay, so let's go ahead with the negative sign. Minus dv0 plus by dt is equal to 1.5 ampere divided by 8 millifarad, right?
यस 8.
is 8 millifarad. Okay, now let us do the calculations. So my response was how, yeah, so this is my response, right? This is my response. So let's put the initial conditions. So uh, sorry, put the initial conditions. So V of 0 plus is equal to 15 volts is equal to VSS plus what, A1 times e to the power S1t plus A2 times e to the power S2t, right? Now VSS is equal to 0. We have already seen this, right? So this will be
Yeah.
equal to, at t is equal to 0, this you have to put t is equal to 0 here, right? So this will simply become 15 volts is equal to A1 plus A2. Fine, this is your equation 1. Now dv0 plus by dt is equal to how much, 1.5 by 8 10 to the power 3 is equal to what? Differentiate it with respect to time,
Yeah.
right?
Yes.
So S1 A1 plus S2 A2, is it correct?
Yes, correct.
Fine. Okay, so what will this be equal to? So S1 and S2, you know, right? If one was equal to
Yes,
0.25,
correct.
you can calculate it
Yes.
from here. So calculate it. So I don't want to do it. Calculate it.
S1 S2 तो कैलकुलेट किया हुआ है सब पर.
Yeah, yeah. So find out the values of A1 and A2 from with these two equations. So let me write it clearly. 1.5 into 10 to the power 3 divided by 8 is equal to, S1 is equal to how much? Is equal to 2 by 8 minus 2 by 8 A1 plus, by the way, this is equal to minus, okay, uh, minus 198 by 8 times A2. Tell me what will be the values of A1 and A2?
ओके सर, कैलकुलेट.
uh,
7.5.
huh?
7.5 सर.
7.5?
आई.
What is 7.5? A1 or A2?
Yes, both same.
Both are same.
Yes, एक मिनट फिर से देख लेते.
Of course. They cannot be same, man.
सेम.
Something is wrong.
यस राइट.
Fine, so calculate it, okay? So let's
ओके
not
सर, हम लोग कैलकुलेट कर
take
लेंगे
time,
सर.
so let's not get into that. Fine.
यस.
Okay, let's calculate, and you will then find, so final response in that case will be equal to what? So you will have a1, you will have calculated a1, you will have calculated a2, you also have the values of s1 and s2, so final response will be this. Okay, so there was a vss term present here, but vss is equal to 0, so I have ignored it simply. Okay, fine.
यस.
So now I have 10 minutes left, right? So let us do another example. Let's do another example. This is based on Laplace transforms.
अनदर क्लास भी है सर हम लोग का 7 बजे से.
Yeah, yeah, I remember
तो
that. I remember that. So that is why I will only talk about one example. I'll talk. This is a very simple example. Okay, so will not take much time. Yeah. So is it visible? Now, can you tell me what is the Laplace transform of this particular d of derivative, nth derivative of delta of t? Can you tell me what is the Laplace transform of this function? You have to use. You have to, for finding out this, you have to know what is the Laplace transform of delta impulse, and then you have to use the property of differentiation. So can you tell me what is the Laplace transform of this
लैपलेस
function?
ऑफ डेल्टा का 1 होता है सर.
Correct, delta का 1 होता है, right? So and nth derivative of delta, so what is that Laplace transform? So let me help you. Okay, this is here in this table. Yeah, you see time differentiation, this is visible, right?
यस.
Yeah, you see time derivative dn of f divided by dt, and this is the nth derivative, and the Laplace transform is what? S to the power n f of s minus s to the power n minus 1 f of 0 minus. You see, for Dirac delta function, all this the value of Dirac delta impulse is equal to 0 at all times except at t is equal to 0. Fine.
यस.
So all the other terms except the first term, in this case the first term will be non-zero, but all the other terms will be 0. Fine.
तो इसका पावर एन से.
Yeah, right. Very good. The answer will be what? S to the power n. Okay.
यस.
Yeah. Now tell me, what is the Laplace transform of this?
4/s + 3/s + 2.
Very good. Very good. Very good. Very good. So this is another table. Okay. You should know some of the basic transforms. Okay. You should remember some basic transforms. So I'll be sharing this slide. You can look it up uh, on the in the drive. So some of the basic transforms you must know. Okay. This is one of the basic transform. So this is the table for some basic transforms. So you should remember this. Well, this was indeed correct. So that will be 4 by s plus 3 by s plus 2. That was indeed correct. This can be found out using this, right? There are a lot of properties here. You can uh, calculate it from here. Fine. Okay. I'm sorry, s plus 2 or s minus 2? Did you say s plus 2?
एक बार फिर से बता दिखाते स्लाइड से उस.
Okay.
s + 2.
Fine. Good. Yeah, fine. S plus 2 it is. Fine. Okay, good enough. So this is, yeah, this is here, right? This is the property here. Can you see this frequency shift? E to the power minus at f of t is transformed to f of s plus a. Fine. This is the property you used, right?
यस.
Yeah. When you go the other way around, so if it is in multiplied in the frequency domain, the time shift is with a sign which is exactly same as the sign here. Here the sign is inverted, right? It is minus a here, but it becomes plus a here. But here you see minus a transformed to minus a only. Okay, so this can be confusing, so you should remember this.
यस, हमें कंफ्यूज होता है टाइम शिफ्टिंग का फ्रीक्वेंसी.
Correct. That is indeed confusing for me also. Okay, so I have to remember it. Anyway, so I will be sharing these slides. Look it up. This is a table. This is kind of an important one. Okay. You should remember some of the Laplace transforms, basic Laplace transforms you should know. Fine, fine. So that's it for today. So thank you for joining. We'll meet in the next session. Okay,
Thank you.
welcome.